Hello Eagles, Mr. Ergel here, and I'm going to put together a little video here to help you kind of review the material in class. These are basically going to be videos that are designed to kind of reinforce what we talked about in class and hopefully give you a better understanding. One of the things that we're going to do is not only talk about the material in class, but I'm also going to have this little card over here, and I'm going to be writing down vocabulary as we go here so that you can kind of see the words as I'm going through the process of explaining things to you, and hopefully that kind of helps you with the language of math. We want to make sure that when we're talking about math, we're using the correct terminology, and so that's what I'm going to do over here on the card. I'm going to put down vocabulary words as we go. So today we introduce number grids, and this is actually the worksheet that I handed out in class to all of the students. And so we began to kind of discuss the grid and the things that kind of stuck out to them, or the things that they noticed about the grid as far as characteristics or traits of the grid. One of the things that came out is that the grid itself is basically made up of rows and columns. And so when we talk about the grid, rows are going to be horizontal, and then columns are going to be vertical. So if we take that concept and we go back over here to the grid itself, so rows are horizontal. They go from left to right or right to left. Okay. Columns are vertical, so they go up and down, up and down, up and down. All right. Obviously, the grid is covered with digits, or numbers, if you will. Digits is another word for numbers. The other thing they noticed was that over here in this column, they noticed that all of these numbers ended in 0. So we began to look a little closer at that to see if we could kind of put some pieces of the puzzle together. And so as we were looking at this, one of the questions I asked them was, how much does each one of these numbers increase? Okay? And remember, the word increase means to get bigger. Okay? Increase is going to be getting bigger. So if we start at the top here and we move down, each one of these is increasing by 10. In essence, as they said in class, they're skip counting. So 10, 20, 30, 40, 50, 60, 70, 80, 90, 100, 110, 120. Okay? So when you move from the top to the bottom, the numbers are increasing. And so each one of these rows, as we discussed in class, basically is adding 10 to the previous number. All right? So as we looked at that then, I began to ask questions in terms of individual numbers on the grid itself. So as an example, if we go look at 25, that's the number I think we chose. If you look at the number 25, and tell me what happens in this row when we move from left to right. So we're just looking at 25, and tell me what each one of these numbers actually do as we move from left to right. They increase, exactly. They increase or they get bigger. Okay? So 25, 26, 27, 28, 29, and 30. Now what happens then if we go from right to left? From 25, if we go from right to left, what happens to each one of those numbers? That's right, they decrease. So decrease means it's going to get smaller. It's going to get smaller. 25, 24, 23, 22, 21. Now, if we look at this again and we say from 25 to the 30, how much is each one of these actually increasing? Well, they're increasing by 1. 25, 26, 27, 28, 29, and 30. Likewise, if we go from right to left, these are decreasing 1 each time we go over. Now the other question I asked was, if we go over here to the far left side, and let's say we just use 31. So if we go to 31 over here, and we look at the number 31 in terms of the ones place and the tens place. So now you have to kind of know a little bit about your place value, and most of you guys are very good about place value. So this is the ones and this is the tens. So we would say there's 1, 1, and there's 3 tens. So what do you notice about the ones and tens digits in the numbers as you go from left to right? As you go from left to right from 31, what do you notice about the ones and what do you notice about the tens? Well, if you look at each one of these numbers as you go from left to right, you'll notice that the tens digits stay the same until you get over here. The tens digit is still the same, but the ones digit has become a 9. From that point, the next box, you'll notice that the digit goes up 1. And then it goes to 0. So the tens digit remains the same across here until the ones become a 9, and then it jumps up 1 and it becomes a 0. So let's go look at another number. Let's say 45. If you add to a number like 45, let's add 1 to that number. Where on the grid is the sum? Well, let's go over here and let's write down the word sum, because that's maybe a new vocabulary word. The word sum is basically used in addition. That's where you'll hear the word sum, and it is the answer to an addition problem. So whenever you hear or read on a test the word sum, they're talking about the answer to an addition problem. So if you add one number to another number, where is the sum? Well, that's the same thing as saying, what is 45 plus 1? 45 plus 1 is 46. Well, where is 46 located? It is located usually to the right. And I say usually because if we're adding to 50, there's no other boxes over here on the grid. In order to go to the next one on this, we can't just go to the right. We actually have to drop down a row and go all the way back over here. 50 plus 1 is going to be 51. So the sum of 50 plus 1 is 51, and it's down one column and all the way back to the beginning of that row. If you subtract 1 from any number, we're going to stick with 45 for this example. If you subtract 1, where on the grid is the difference? And the word difference is another vocabulary word that I'll put over here. Difference is used in subtraction. The difference is also the answer in a subtraction problem. So when you subtract 1 from 45, where is the difference located? Usually it's to the left. 45 minus 1 is going to be 44. And it's usually to the left. Unless there's a 1 in the ones place. As an example, if we go to 41, 41 minus 1, there is no grid over here, so we have to go up a row and go back over here to this side. So 41 minus 1, the difference is located up one column all the way over to the end. I'm sorry, up one row, excuse me, and then all the way over here to the end. Now, what do you notice about the digits as you go from top to bottom? As you go from top to bottom. So let's go over here to the 1. And as you look at this from top to bottom, what is it you notice about those digits? Look at these numbers here and see if you can identify anything in particular about those. Well, if you look at these, the ones digit stays exactly the same in all of these, all the way down. Same thing with the fives. If you look at the fives and go down, the ones position is always going to be a 5 until you get to 100. Then you exchange all your 10s for 100 and start over with 0 in the tens place. So as we talked about the grid earlier, we talked about how as you move down in this column, you're adding 10. Let's go try something very quickly here. If you go to the 5 in the second column here, and you go down one row, what happens to the 5 when you go down one column or row? When you go from the 5 down one, it increases that number by 10. The same as it increases by 10 over here in the left, far right column. So each one of these movements as you go down from top to bottom is actually increasing this top number by 10. So 5 plus 10 is 15, plus 10 is 25, plus 10 is 35. Why is this important? Well, this is important especially when you're trying to solve computations or problems. Computations is another vocabulary word, and it's just another word for problems. If you're trying to solve computations, you're trying to solve problems in math. So, with all of that in mind, as you go down, you're increasing by 10. Likewise, if you're going up from 45, you're going to decrease by 10. 45, 35. 35 minus 10 is 25. 25 minus 10 is 15. And 15 minus 10 is 5. I hope this kind of helps you. I've gone a little long on this video. I was trying to keep the videos rather short, but hopefully between the vocabulary that we've kind of covered here and the material that we've covered here, I'm going to make this video, I'm going to cut it here, and then I'm going to have another video to talk about how to actually use the grid when you're trying to solve math problems. Thanks so much for watching, and I'll see you in part 2.